Good afternoon, class. Here's Chapter 4, Application of Derivatives, Section 4.2, How Derivatives Affect the Shape of a Graph. The function f of x equals 1/2 x to the power of 4 minus x squared. And before we use the calculus, I want to use pre-calculus algebra to graph this by simply finding intercept. So if you set it equal to 0, that means you can factor either the x squared or half of x squared. And if you do so, you get half of x squared times x squared minus 2 equal to 0. This gives you 0. This gives you x squared equals 2. X is plus minus square root of 2. And we have the following intercepts, 0, 0, happen to be both x and y intercept. Also, because this has exponent 2, it has multiplicity 2. So if we were to graph this just like that, so we have 0, 0 with multiplicity 2, that means this. We have square root of 2, by the way, is almost 1.41. So roughly here, and negative roughly here. And this tells me the end behavior looks like x squared. And if we were to graph it, as it is the first x-intercept, it crosses, it penetrates the x-axis. It has to come back at some point. We may not know at what point. It hits the second one, but it can't cross because the multiplicity is 2. It bounces back. And at some point, it has to back up. So we may not know exactly where. That's why we add the calculus. However, one of the things that we did in algebra that was helpful, we looked at even and odd. If you write f of minus x equals f of x, and I'm going to leave it for you to prove that, you can see that that means symmetric with respect to the y-axis. The right half and the left half are identical. So that's a graph using information from pre-calculus algebra unit. Now, let me erase the work, and to get to first derivative test, we have to find f prime of x. To find f prime of x, it's a simple case of 1/2 times 4, 2x cubed minus 2x. We need to set it equal to 0. We factor the 2x out. When we factor the 2x out, we get x squared minus 1, and x squared minus 1 is x plus 1, x minus 1. And now we have three answers. X is 0, x is negative 1, x is positive 1. So there are three critical points. We go with the number line from negative to positive infinity, and we put three numbers in order from smallest to largest, negative 1, 0, 1. And we can pick up a test point for each region, each sub-interval. I'm going to call it TPs. So like negative 2 here, negative 0.5 here, 0.5 here, 2 here. Now, before we move on, we should recognize they are going to alternate, because if you look at this one, or going back to this one, it has degree 3 and it has 3 answers. So each one has exponent 1, which is odd, so they must alternate. 1, 1, 1. So with that being the case, if you plug in 2, whether you put it here or here, it makes no difference. For example, here 2 cubed, 8 times 2, 16, minus 2 times 2, 4 is 12. So this is positive, and the rest of it alternate. Or as I mentioned, even you can put it in here. One thing I want everybody to pay attention to, if you go with that, and sometimes it's easier, pay attention that the coefficient is 2, positive has no bearing. This were negative would change everything. That's why sometimes you want to go with that to be on the safe side. Now, if I put if I put the 2 here, I get this is positive, 2 plus 1 is positive, 2 minus 1 is positive, all positive. If I put 0.5, positive, 0.5 and 1 positive, 0.5 minus 1 is negative 0.5, and that's why we get those. So all we have to do now, we are going to let's throw in the arrows, the down arrow for negative, up arrow for positive. So negative means decreasing, positive means increasing. So as it changes from decreasing to increasing, it gives rise to a local minimum. So -1 as well as +1, they give us local minimum. Whereas over here, increasing to decreasing, 0 gives us local max. So we're going to put -1 and 1 into this, and we can do both of them the same because the exponents are both even. So it doesn't matter you put positive or negative, you get to the same answer. This is 1, this is 1. So you get 1/2 minus 1, which is -1/2. 0 is easy, everybody. If I plug in 0, I get 0. So we are going to write local minimum is equal to -1/2 at plus minus. We write it as 2 pairs. Local maximum, as I said, if you plug in 0, you get 0. So local maximum is 0 at x equal to 0, or this pair. Now, it's decreasing here from -infinity to -1. Also here, union 0 to 1. It's increasing here and here. That means it's increasing from -1 to 0, union 1 to infinity. And we write it in this fashion. So we are going to move on to the next page. And continue with that. So it's the same question, same function. We have already f prime. We have already the intercepts, mean, max, increasing, decreasing. So what you see here is the information from before. Now we need f double prime. So 2 times 3, 6x squared minus 2. And to set this equal to 0, we factor the 2 out. Three x squared minus 1 is 0. 3x squared is 1. X squared is 1/3. And x is plus minus 1 over square root of 3. We are going to figure out whether we have inflection points or not. Those are possible points. So we put a number line from negative to positive infinity, and we put the two numbers. And the TPs, test points, everybody, Obviously, in between would be 0. Remember, square root of 3 is larger than 1, 1.7. So 1 over square root of 3 is less than 1. So over here would be 1, over here would be -1, or you can pick anything else. And they will alternate because the degree is 2 and it has two answers. So plug in 0. And if you plug in 0, you get -2. And they will alternate. So this is negative, positive, positive. So what does that mean? The change in sign indicates those are the inflection points. Positive, concave up, negative, concave down. So it's concave down here from -1 over square root of 3 to 1 over square root of 3 is concave down. From negative infinity to -1 over square root of 3 union 1 over square root of 3 to infinity is concave up. And the inflection points, you have to plug in these two numbers into the original function. And because the exponents in both cases is 4, you can do them at the same time. Plug in 1/2 times plus minus 1 over square root of 3 to the power of 4 minus, the parenthesis plus minus 1 over square root of 3 quantity squared. I'm going to do this one first. I want to show you that quickly. This one becomes 1 to the second power is 1, 3. Square root of 3 to the second power is 3. So it's 1/3. If this is 1/3, this is 1/3 squared, or 1 over 9. So we write 1/2 times 1 over 9 minus 1/3. So 1/2 times 1 over 9 minus 1/3. This gives us 1 over 18. This gives us 6 over 18. So -5 over 18. So we write the inflection points at plus minus 1 over square root of 3, comma minus 5 over 18. And this is an approximation for the sake of graphing, everybody. Let's write the summary of what we have so we can graph. The first one is plus minus square root of 2, 0, and we're going to go with roughly 1.4. Here's 1, here's 2. So 1.4 is roughly here. Negative 1.4 is roughly here. We have those two pairs. The maximum occurs at 0, 0. This is not only the x-intercept, it's also a maximum, so we draw a double arrow, meaning as it hits it, the graph hits that and it bounces back. The IPs at plus minus 1 over square root of 3, comma minus 5 over 8. We go with this 0.6 and negative 0.3. So 0.6 roughly here. And it goes down by 0.3, negative 0.6 roughly here, and it goes down. So we have these two pairs. The minimum at -1, -1/2, and minimum means again we need a double arrow. So this is -1 and go down by 1/2. This is +1 and go down by 1/2, and each one takes an arrow. And going back to the leading term, as I mentioned, the first and the second quadrant, those are the end behavior simply because it behaves like x squared. The graph looks like that. The number of bacteria in millions present in a culture at time t in hours is given by n of t equals 2t times 5 minus t squared plus 14t plus 100. Find the initial population. Pass. This is elementary algebra. Basically, it's asking you to plug in 0. Initial population t is 0. And I hope you recognize this one as 0. This one as 0. You get 100. 100 what? Million bacteria. At what time before 10 hours will the population be maximum? First of all, at what point before 10, that means negative infinity to 10. Because it's time, it's 0 to 10. And because it's before 0 is included with a bracket, 10 is not, because it says right before. And I'm going to simplify this. This becomes 10t minus 2t cubed. I put this one first. I add these two, and I get negative 2t cubed plus 24t plus 100, going from 0 to 10. 0 is included, 10 is not. And so I remind you, when we have an extreme value theorem or closed interval theorem, as long as both sides, it's a continuous function, which is a continuous function polynomial of degree 3, and both sides are closed, you have to check the endpoints and the critical point. The endpoints 10, we don't have to check. The endpoint 0, we must check. We already have the answer. So let's find the critical point by finding n prime of t. N prime of t, negative 60 squared plus 24. Factor out the negative 6, you get t squared minus 4, which is t plus 2, t minus 2. You have two critical points. If you set this equal to 0, plus minus 2. Can we use both? No. Negative 2 cannot be used. We can only use t equals 2. This must be the point that we check also. But let's look at the first as well as the second derivative test to see what they indicate. So if you go with the first derivative test, which means a number line from negative infinity to positive infinity, we're going to go from 0 to 10 because of this restriction. At 2, it n prime becomes 0. So if you pick a test point, and actually you can use even 0 and 10 as 10 points. If you plug in 0, you get positive, 10, you get negative. So positive, negative, and we throw in the arrows. Positive means increasing, negative means decreasing. And because it changes from increasing to decreasing, then it must be a local max. And in this case, it will be an absolute max. What about the second derivative test? So we're done. We don't have to use the second derivative test, but this is the application. Second derivative test, you can forget about the sign graph. It's easier. What is the second derivative test? Find n double prime, which is negative 12t. Plug in number 2, the critical point, and observe if it's positive or negative. When you plug in, you observe that it's negative, and that's all we want. We just want the sign, everybody. Doesn't matter how big or small. Negative means what? Concave down. Concave down means what? Maximum. So maximum occurs at t equals 2. So what is the maximum population? Plug in 2. Doesn't matter the original one or the one that I simplified. Either way is fine. So this one is 4. 5 minus that makes it 1. 2 times 2, 2 is 4. This is 28. They add up to 32. So 132 million. I think it was a tad easier to go with the original one. We want to sketch the graph of f of x equals x minus 2 to the power of 2/3 plus 1. And what I'm going to do, we want to sketch the graph. Therefore, we are going to rewrite this as cube root of x minus 2 quantity squared plus 1. In pre-calculus algebra, what we did the transformation. Let's start with one of the essential functions, elementary functions. We should know the graph of cube root of x, which looks like this. Then we are going to go with cube root of x minus 2. And of course, the x-intercept is at 0, 0. We're going to go with cube root of x minus 2, which means this one we are going to change it to x minus 2, shift it to the right by 2 units. So the same graph, move it to the right by 2 units. So 0, 0 now goes to 2, 0. The next step is to square that. How do you square a function? There are two parts. The part that is positive becomes simply larger. The part that is negative, remember, positive or negative makes no difference when you square it becomes positive, so it flips over. So the portion which is positive remains positive, but larger. The portion which is negative will flip over, and the location of the intercept doesn't change. Next step, we add 1. That means this green one, bring it up by 1 unit. So bring this one up. When you do that, now 2, 0, which remains 2, 0 here, now becomes 2, 1. And you're done. That's the graph, everybody. Now, we are going to do calculus. And with calculus, the very first step is to find the relative extrema. That means do the first derivative test. That means given f of x, we want f prime of x. So how do we find f prime of x? It's easier to go with this one, 2/3 x minus 2 to the power of 2/3 minus 1, which makes it negative 1/3. The derivative of the parenthesis is 1. So 2/3 times x minus 2 to the power of negative 1/3. We take this to the denominator, make it positive 1/3 or a cube root. Because we are looking for CPs, we look at two things. F prime of x is 0. F prime of x is 0. If it's a fractional form where the numerator is 0, numerator is a number, doesn't give us any solutions. Or f prime does not exist, that means a fraction is undefined, that means the denominator must be 0. Clearly, you see when x is 2, it makes it 0. So with that being the case, we can go with a number line from negative to positive infinity. We put x and f prime. There's only one critical point. We put it here at 2. F prime does not exist. And so what do you do? Test points. TPs to the left, of course, 0, to the right, let's say 3. And if I plug in 0 here, everybody, we are looking at f prime. I get negative. Cube root of negative is negative. times 3 is still negative. 2 divided by negative is still negative. So 0 gives us negative. What about 3? 3 minus 2 is positive. Cube root of a positive number is positive. Everything becomes positive. So negative and positive. Again, I'm going to throw in arrows. Negative means decreasing. Positive means increasing. So as it changes from decreasing to increasing, gives rise to the location of a minimum. The minimum occurs at x equals 2. Put it into the original function to find the y coordinate. And if I put it in here, this goes to 0, I get 1. It's a very easy evaluation, or this one for that matter. So local minimum equals 1 at x equals 2, or the pair 2 comma 1, we have nothing else, so there is no local max. So the function is increasing here from 2 to infinity and decreasing here from negative infinity to 2. So that's very straightforward. We write it. Now the next one is inflection points. Do we have any? We have to go with the next part, which means we have to differentiate it again. In other words, we are looking for f double prime. So we go back to f prime in this format and differentiate this one. 2/3 times negative 1/3, negative 2 over 9, x minus 2 to the power of, subtract 1, minus 1/3 minus 1 is minus 4/3. So that's f double prime. Negative exponent, take it down, make it positive. And you may notice that you really don't have to do much. You'll notice that because this is exponent for whatever this is becomes positive, times 9 is positive, but this guy makes it always negative except at x equals 2. Why not? What happens at x equals 2? The denominator becomes 0. F double prime does not exist or is undefined. So this is always negative because of this number, except at x equals 2. So right away, you can see it's concave down all the way from negative to positive infinity. However, the way you write it is not from negative to positive infinity. The way you write it, from negative infinity to 2, union 2 to infinity. You have to write it in this fashion, okay? Now, just in case, and you don't have to, if you want to go with the sign graph, if double prime is 0, never, because the numerator is a number, does not exist when the denominator is 0, 2, you go with the number line. From negative to positive infinity, add 2, f double prime doesn't exist. Obviously, again, we're going to use the same 0 to the left of 2, 0, and to the right, let's say 3. So if you plug in 0, what happens here? You get negative 2. Cube root of negative 2 is negative. Take it to the power of even. Number 4 is even, positive, and so forth. So it becomes positive. If you plug in 3, this is positive, the same thing. Everything is positive in the denominator. So what happens with this negative? It's always negative. So the same answer. So you don't have to do that. Now, this is the function, and we want a graph We have everything except we didn't do the intercepts. Let's do the intercepts. So if I plug in x equals 0, I get minus 2 to the power of 2/3, or you can put here minus 2 squared is 4, cube root of 4, plus 1. Now, cube root of 4 plus 1 is roughly 2.5874 or 2.6. This is for the sake of graph, okay? This is exact. There is no x-intercept. Why is that? Let's see why it's not giving us any answer. X-intercept means y or f of x is 0, set it equal to 0. We're going to move the 1. Anytime you have an equation that has an exponent which is a fractional format, we raise both sides to the power, which is the denominator first. So the left side becomes x minus 2 squared. The right side becomes minus 1 cubed, which is negative 1. This expression is always positive. Worst case scenario is 0. This is always negative 1. Can't be. No solutions. Sketch the graph. We are going to use what we have. And if it's not good enough, we're going to use extra points. Those are easy points we're going to use. First, points that we can easily calculate. If I plug in 1, minus 2 becomes negative 1, cube root is negative 1 squared, positive 1, and 1 is 2. If I plug in 3, I get the same thing because 1, cube root is 1 squared is 1, and 1 is 2. Those are easy points. These 3 points are also easy. This one you need, I just wanted to throw in some number that requires a calculator. But what about negative 6 and 10? Because it's a cube root, I'm going to make a negative 8 or positive 8. To make a negative 8, I need negative 6. Comes out as negative 2 squared is 4, and 1 is 5. If I want to make it 8, I put 10. 10 minus 2, 8. Cube root is 2. 2 squared is 4, and 1 is 5. And I'm going to start putting in the first number, 0, and 2.6 is roughly here. 1, 2, 1, 2 is here. 2, 1, 2, 1 is here. 3, 2, 3, 2 is here. And by the way, this is the minimum. That's good enough. You can go like that. But let's say negative 1, 3.08 is a little bit above 3, just a tad. Negative 6, this is negative 5. Negative 6, go up by 5 here. 10, 5, 10, 5 is here. Put them all together. You're done. What else do we notice? The function is decreasing here. The function is increasing here. Also, the function is concave down here as well as here, which we cannot write from negative to positive infinity, rather negative infinity to 2 union 2 to infinity.